The universe looks like a vast empty ocean sprinkled with rare islands of galaxies. But this is an illusion. Just a small fraction of all atoms are found in galaxies, while the rest is thought to be drifting in between, in the intergalactic medium. Like the roots of some massive tree, gas spreads out from each galaxy, gravity funneling fresh mass into this dense cosmic forest. Here in the intergalactic medium are the raw materials of creation: hydrogen and helium, woven into sheets and filaments that flow into galaxies where they eventually create stars. But if we look closely, we see who's actually in charge: quasars, the single most powerful objects in existence. As small as a grain of sand compared to the Amazon River, they reside in the centers of some galaxies, shining with the power of 1 trillion stars, blasting out huge jets of matter, completely reshaping the cosmos around them. They're so powerful that they can kill a galaxy. What are they, and how do they mold the structure of the universe at their whim? Everywhere you look, weird things in the sky. In the 1950s, astronomers noticed mysterious loud radio waves coming from spots all over the sky. They were named quasi-stellar radio sources, or quasars, because they were dots like stars but were seen in radio waves rather than visible light. Everything about them was strange. Some flickered, others emitted high-energy X-rays in addition to radio waves, but all seemed to be tiny. They all moved extremely fast, as much as over 30% the speed of light. The only explanation was that they must have been so distant that their apparent speed was actually the expansion of the universe moving them away from us. But these enormous distances meant that quasars couldn't just be stars, but the active cores of galaxies billions of light years away. And it gets crazier. To appear so bright and loud, given these vast distances, they are thousands of times brighter than the entire Milky Way. Monsters exploding and screaming into the void with a violence not thought possible before. As we mapped the sky, we discovered over 1 million quasars, and they all seem to be very far away. Looking into space far away means very long ago, because light takes so long to reach us. Quasars were common in the early universe, having peaked in number 10 billion years ago when galaxies and the universe itself were still very young. Let's go back in time just 3 billion years after the Big Bang and see what was going on back then. The incredible power of quasars. How could an early baby galaxy be so incredibly bright and violent? All that light and radiation couldn't be stars, as there weren't nearly enough of them. And since galaxies tend to grow with time by merging, the starlight from small galaxies shouldn't be far brighter than any galaxy today. There's only one way to generate the vast amounts of energy a quasar shines with: feeding supermassive black holes. We still don't know how exactly they formed, but it seems that every galaxy has one in their center. But how can the brightest things in the universe be black holes which trap anything and everything that crosses their event horizon? Well, the light of a quasar is not coming from inside these black holes. Rather, it comes from the space around them, a massive orbiting disk of gas called an accretion disk. Quasars use the same fuel as stars to shine: matter. It's just that black holes are the most efficient engines for converting matter into energy in the universe. The energy released by matter falling into a black hole can be 60 times greater than that released by nuclear fusion in the core of a star, because the energy released by a black hole comes from gravity, not from nuclear reactions. Matter falling into a black hole speeds up to almost the speed of light before it crosses the event horizon, buzzing with an incredible amount of kinetic energy. Of course, once inside the black hole, it takes that energy with it. You only get to witness this energy if you drop your matter in the right way. Fall straight down and the outside universe gets nothing. But when you have a lot of matter, it spirals in incredibly fast towards the event horizon, forming a disk. Collisions between particles and friction heat it up to hundreds of thousands of degrees. In a space not much bigger than our solar system, the core of a galaxy can release many times more energy than all its stars combined. This is what a quasar is. A supermassive black hole having a feast. And these black holes eat a lot. Typical quasars consume 1 to 100 Earth masses of gas per minute. 10 billion years ago, the universe was about a third of its current size, so the intergalactic medium was much less spread out, meaning the filaments of gas around quasars could feed them a banquet, making them vomit insane amounts of light and radiation. The brightest quasars power jets, tangling the magnetic field of the matter around them into a narrow cone. Like a particle accelerator, they launch enormous beams of matter out, ploughing through the circumgalactic medium, forming plumes of matter that grow to hundreds of thousands of light-years in size. It's almost unfathomable in scale. A tiny spot in a galaxy carving out patches of the universe hundreds of thousands of light-years long. But quasars can't eat for long, maybe a few million years, because their feast ultimately kills their galaxy. How quasars kill galaxies? Okay, maybe killing is a bit of an exaggeration. A galaxy is still there after its quasar turns off, but it will never be the same again. Quasars, being among the hottest and brightest things in the universe, break their galaxies by heating them up too much and stopping star formation. Stars are gas that collapsed in on itself and then got really hot. But in a cloud of gas that's already hot, atoms are moving quickly. When they collide, they hit hard, exerting pressure that resists gravity's squeeze. So hot gas cannot form stars. Instead, the best gas for forming stars is already cold and won't put up a fight when it's time to collapse into a star. On top of that, quasars push gas out of their galaxies. Not only does this starve the quasar, but its galaxy loses the raw materials for new stars. As sad as this sounds, it might be a good thing for life. The alternative can be far more dangerous: too many stars. New stars forming is usually followed by massive stars exploding in supernovae, so planets would be burned sterile. But of course, it's more complicated. Like the intricacies of our own planet's biosphere, every piece of the galaxy is dependent on and influencing every other part of the galactic environment. While hot things like quasars and supernovae tend to push gas out of the galaxy, shockwaves and quasar jets can also compress gas, making new stars at least for a short time. But in general, we can say that without things becoming a bit more chill, we would not exist today. Which brings us to our final question. Did the Milky Way have a quasar in the past? It's unclear if every galaxy went through a quasar phase, but understanding distant quasars may provide clues to the history of the Milky Way. Galaxies don't do a good job of preserving their history. Like sand on a beach, the endless churning mixes away the clues to their past. It's possible the Milky Way was once a quasar, which may have allowed our supermassive black hole Sagittarius A star to have grown to 4 million times the mass of the Sun. And as dormant as it is now, Sagittarius A star could turn into a quasar in the future. In a few billion years, the Milky Way will merge with Andromeda. We've seen over 100 double quasars in galaxies smashing together, where fresh gas is provided for the central black holes. But it won't last for long. When galaxies merge, so do their supermassive black holes, sinking into the center of their new galaxy, kicking up dust and stars in every direction. We don't know whether this will happen, but it would truly be an incredible sight. Maybe some beings in the far future are going to witness it and be in awe of what they see. But you don't have to wait that long. There are already plenty of fascinating things to explore right here on this planet, right now, if you have the knowledge to understand them. To help you with that, we've created a series of lessons to take your scientific knowledge to the next level. Made in collaboration with our friends at Brilliant.org, these lessons give you a deeper understanding of the topics from our most popular videos, from rabies and mammalian metabolism to climate science. There's also a lesson on black holes, where you can delve into the fundamental principles behind their formation and behavior. A deeper understanding will also help you appreciate their role in powering the quasars we talked about in this video. Brilliant is an interactive learning tool that makes maths, science and computer science accessible with a hands-on approach. Because we know that to really learn something, you've got to do it. Think of each lesson as a one-on-one tutoring version of a Kurzgesagt video. Brilliant has thousands of other lessons to explore as well. From maths-based topics like algebra and probability to courses around programming and data science. Their latest course, How Technology Works, takes you inside the technology you use every day. You'll walk in the footsteps of a hacker to discover why some passwords take decades to crack, explore how satellites in space know that your rideshare driver is just down the street, learn why your favorite Kurzgesagt video might buffer on YouTube, and more. To get hands-on with Kurzgesagt lessons and explore everything Brilliant has to offer, you can start your free 30-day trial by signing up at brilliant.org/nutshell. There's even an extra perk for Kurzgesagt viewers. The first 200 people to use the link get 20% off an annual membership once their trial ends. We love seeing how the gears interlock with our research. Brilliant gives you the tools to understand how everything fits together. We know you've been waiting for a long time. Let's reveal the next limited edition pin. It's the Dyson Sphere. This very special pin set represents our dream for the future of humanity. Charge it with energy from the sun and it will glow in the dark. Pre-order is available for only 72 hours, so order now before time runs out. The next limited edition pin will be revealed soon.